By the time the modern world arrived, the golden ratio had already gathered a reputation larger than itself. It was no longer just a mathematical relationship. It had become a symbol, a promise that beauty could be explained, measured, reproduced, and this is where the story takes a turn as science advanced. Mathematicians became cautious. They learned an important lesson again and again. Whenever a simple formula claims to explain something deeply human, skepticism is necessary. Beauty is not. Like gravity, it does not behave the same way in all contexts. It does not submit easily to equations in the 20th century. Researchers began testing claims about the golden ratio more carefully. They measured faces judged attractive across cultures. They analyzed artworks, buildings, and natural forms. The results were subtle. Sometimes proportions near the golden ratio appeared. Sometimes they did not. What emerged was not a rule, but a pattern of preference. Humans tend to like proportions that feel balanced, but balance itself is flexible. It shifts with culture, experience, emotion, and meaning. The golden ratio is part of that landscape, not its ruler. This did not stop the myths. Design books began to promise perfect layouts using the golden ratio. Websites claimed logos were secretly beautiful because of it. Faces were analyzed with grids and lines, as if attraction could be reverse engineered. But something important was lost in this obsession. The golden ratio was never about control. It was about growth. When mathematicians first encountered it, they were fascinated not by its beauty, but by its behavior. It emerged naturally from recursive processes. It appeared in limits. It connected algebra, geometry, and number theory in unexpected ways. Its beauty was a side effect, a quiet one in nature. The golden ratio does not appear because nature aims for elegance. Nature aims to survive. Plants grow in patterns that minimize competition. Shells grow in spirals because expanding while maintaining shape is efficient. Trees branch in ways that distribute stress and light effectively. Mathematics appears not as decoration, but as consequence, and humans standing inside this world evolved brains that respond positively to such efficiency and balance. We find beauty where systems work well. This may be the deepest connection between mathematics and aesthetics. Think again about the spiral. A spiral suggests motion without chaos, change without collapse, growth without distortion. It is not static. Perhaps that is why it feels alive. Humans are drawn to patterns that suggest continuity, that promise stability while allowing movement. The golden ratio often sits at that threshold, not frozen, not explosive, but unfolding. Modern neuroscience offers one more clue. When people view images with balanced complexity, their brains show reduced cognitive strain. Visual processing becomes smoother. The mind does not need to fight the image. It flows with it. This flow state feels good, not exciting, not dramatic, but calm. Beauty, in this sense, is not stimulation. It is relief, and mathematics quietly describes the conditions under which that relief occurs. This explains why the golden ratio often appears in calm designs rather than loud ones. It is not the ratio of spectacle. It is the ratio of rest. A whisper, not a shout. At this point, a question becomes unavoidable. If beauty can be partially explained, does that make it less meaningful? The answer is no. Understanding why music moves us does not silence it. Understanding why balance feels good does not remove wonder. If anything, it deepens it. Mathematics does not drain beauty of mystery. It shows us that mystery has structure, and perhaps that is why humans care so deeply about beauty at all. Beauty is not a luxury. It is not decoration. It is a signal that something fits, that something works, that something belongs in a chaotic universe. Beauty reassures us that order is possible, even if incomplete. The golden ratio does not explain all beauty, but it reminds us that beauty is not accidental. Now let us return to the question that began this journey. Why do humans find certain things beautiful? Not because we calculate, not because we measure, but because our minds evolved inside a world shaped by growth, balance, and constraint. The golden ratio is one fingerprint of that world, not the only one, but a memorable one. Pause for one final moment. Look at something you find beautiful, a natural scene, a face, a piece of art. Ask yourself, do I love this because it follows a rule, or because it feels alive? Mathematics does not choose between these answers. It stands quietly in between. The golden ratio is not a commandment. It is an invitation to notice, to reflect, to wonder why order and emotion intersect at all. That intersection is where mathematics becomes human. If you've enjoyed this journey from shells to faces, from spirals to the mind, then you are exactly where you belong. Subscribe to Maths Whisperer here. We learn math with stories, stories that do not rush, stories that respect mystery, stories that understand that numbers can be felt as well as known. In the next episode, we will step into another quiet question. Is randomness truly random, or does it only appear that way? Until then, stay curious.